Hello class and welcome to Unit 8 Video 6. Today we're going to look at operations with radical expressions. Today you're going to learn to add, subtract, multiply, and divide radical expressions. And we already have done some multiplying and dividing in our last notes video. One thing to remember is that when you are simplifying, you cannot have a radical in the denominator or a variable with an exponent. Not with an exponent, but excuse me, a variable with a fraction in the exponent. So if you have 1 over x to the 1/2, you cannot have that because really this is 1 over the square root of x. You need to rationalize. So biggest thing is to simplify, you must rationalize all the way. So the first thing we're going to look at is adding. So to add, and it's the same thing for subtracting radicals, you add and subtract radicals in the same manner as adding and subtracting monomials. You can only add or subtract like terms or like radicals. Okay, so what they're talking about is if we have x plus x, that becomes 2x. You can add those, they're exactly the same. If you have x plus x squared, you cannot add those because they're not like terms. Okay, so today if you have square root of 2 plus square root of 2, I would have 2 of the square roots of 2's. So that's what you're doing today. Some things that we have is we can add when it's exactly the same. We have a cubed root, so same index, okay, and we have 3a underneath the radical. Okay, so we can add them. 2 plus 6 would be, in this case, we would have 8 cubed root of 3a. Okay, so that's allowed. This you cannot do. Okay, this is a 3a and this is an a, so those are different. Also, if your index are different, you cannot add them. Okay, so these are bad. We dislike those. Okay, so let's go ahead and simplify. Example 1. Okay, I right away look at these. I have radical of 12, radical 27, and radical 48. None of those are the same, but I try and see if I can simplify them. 12, I would break down. I know that it is the square root of 4 times 3. Minus 3 square root of, well, I know this is 9 times 3. Plus, okay, 48 gets a little bit bigger, but notice how this is a perfect square and this is a perfect square, so I'll have a 3 underneath. So let's just try 48 divided by 3, see if it works out. Look at that, 16, and the square root of 16 is a perfect square, so we would have 16 times 3. Now let's go ahead and simplify. Square root of 4 is 2, so I have 2 times 2 square root of 3, minus 3 times square root of 9 is 3, square root of 3, plus 2 times square root of 16 is 4, square root of 3. So 2 times 2 is 4, square root of 3, minus 3 times 3, which is 9, square root of 3, plus 2 times 4 is 8, square root of 3. Then I can combine my like terms. Since they all have a radical of 3, we would say 4 minus 9 is negative 5. Negative 5 plus 8 is 3, so I have 3, square root of 3. There is my answer for example 1. Example 2, same type of idea. Let's go ahead and start breaking it down. I know that 8 can be broken down into 4 times 2. Square root of 4 is 2, so we have that. So I'm going to try and see if 32, what is it? What is 32 divided by 2? It's 16, so 16 times 2. Minus 4 times, what's 18 divided by 2? It's 9 times 2. So sometimes they're going to work out fairly nicely for you. So if you see what's going to be left underneath, you can try and divide by that number. So I would have 3 times square root of 4 is 2, square root of 2, plus 5 times square root of 16 is 4, square root of 2, minus 4 times square root of 9 is 3, square root of 2. 3 times 2 is 6, square root of 2, plus 20 square root of 2, minus 12 square root of 2. Once again, my radicals are all the same, so I can add them. 6 plus 20 is 26. 26 minus 12 is 14, square root of 2. And there is my final answer. Okay, so that's adding and subtracting. Now, examples 3 and 4 are multiplying. Okay, when I'm multiplying, if I have 2 binomials essentially, is what it looks like, you have to FOIL. Have to use that process of FOIL. So our first multiplied. So 2 is not a radical, so I would take 2 times 3, which is 6, square root of 5. Then I take my outer 2. So it's 3 square root of 5 times square root of 3. So plus, it's going to be 3. 5 times 3 is going to be square root of 15. Now my inner 2, that's what I stands for, I would have negative, it's 2 times 2, so 4 square root of 3. And positive times a negative will give me minus, and then I would have 2 times 3, square root of 9. Let's go ahead and simplify. This one, I would have 6 square root of 5 plus 3. Can I break this down into any perfect squares? 3 times 5, nope, neither one are perfect squares, so 15 minus 4 times square root of 3, that can be broken down, minus 2 times square root of 9, this is really 3. 2 times 3 is 6. Okay, all these radicals are different, so I cannot combine them. So this is actually my final answer for multiplying. Okay. Example 4. Once again, we're multiplying, so we need to FOIL. So if I take the first two, I'm going to make a little note, we're FOILing for this one. So I take 5 times 5, which gives me 25. Then it's square root of 3 times 3, which gives you square root of 9. Okay. Then I take this times 6, so it's plus 6 times 5 is 30 square root of 3. Minus 6 times 5 is 30 square root of 3. And then negative 6 times 6 is negative 36. Once again, I would look to see if I could combine like terms. 25 times square root of 9 is 3, so that's actually going to be a number. 30 square root of 3 minus 30 square root of 3, those will cancel. And then minus 36. 25 times 3 is 75 minus 36. 75 minus 36 is 39. Okay, this is a special case. This is what we call the conjugate. Notice it's exactly the same except for one's a negative and one is a positive. So when you multiply by the conjugate, you are left with just a number. So this is a nice little trick that we're going to be using when we simplify with fractions. So it's a conjugate. There's a quicker way to get it. Do you guys remember difference of perfect squares? Okay, if we had x squared minus y squared, you could factor that as to x plus y and x minus y. Well, essentially what you could do is if I took my beginnings, this is really like my x, and this is like my y, and you square them, so if you take 5 square root of 3, and you square it minus your y value at 6 squared, you would have 25 square root of 3 squared is 3 minus 36. Isn't that what I had above? Yes, it's 75 minus 36, which will leave us with 39. So if you don't want to FOIL it all out, you can remember this little move with difference of perfect squares. If not, just FOIL it out and you'll still get the same answer. So that's a little trick. If you have any questions about that, feel free to ask me. Otherwise, I'm just going to use FOILing for the rest of them. Okay. So example 5 and 6, now this is our division. Okay. We have a binomial in the denominator or two different parts. So we cannot just go ahead and rationalize like we have in the past. If our problem was something like this would not be a problem. I would just multiply by square root of 3. However, I can't because there's that 5 on this time. So what I need to do to get the radical out of there is use the conjugate, which is what we had here. Notice, once again, it's exactly the same except for one's plus and one's minus. So my conjugate for this one would be, this is a plus, so it's going to be 5 minus square root of 3. And then we need to FOIL. Okay, so FOILing the top. So we have 5 minus square root of 3 minus 5 square root of 3. Negative times negative will be plus square root of 3 times 3 is 9. All over 25 minus 5 square root of 3 plus 5 square root of 3. And then minus square root of 3 times 3 would be square root of 9. And now simplifying. This is really 3. These cancel. This is really 3. So let's see what we have. So this will equal 5 plus 3 is 8. Negative 1 square root of 3 minus 5 square root of 3. So negative 1 minus 5 is negative 6 square root of 3. All over 25 minus 3 is 22. Okay. So far, this is my answer being simplified, because remember, I can't have that radical in the denominator. If you take the conjugate and you still have a radical, probably made a mistake. So we know we didn't make a mistake because it's a number in the bottom, so that's good. Now the next thing I would look is, can it be simplified further? This, and this are all divisible by 2. So I'm going to factor out a 2. So I'd have 2, 4 minus 3 square root of 3. Oops. There we go. 3 square root of 3 all over 22. 2 and 22 divide, so I have 4 minus 3 square root of 4 minus 3 square root of 3 all over 11. And that is my final answer for number 5, because it cannot be simplified any further. Okay. Moving on to example 6. It's fairly similar. We need to simplify, so we can't have that radical, so I know I need to use the conjugate. Once again, this one is plus, so I'm going to write it with minus. It's always the opposite sign, so it's 6 minus square root of 5. And FOIL. Okay, I would recommend you pause the video and FOIL this one on your own, and then check how you did. So we would get 18 minus 3 square root of 5 minus 12 square root of 5 plus 2 square root of 5 times 5 is 25. All over 36 minus 6 square root of 5 plus 6 square root of 5. Then lastly, we'd have minus square root of 25. If I start to simplify, this is really 5, so it's 2 times 5. These cancel, and once again, this is really 5. So I would have 18 plus 2 times 5, which is 28. Negative 3 minus 12 is minus 15 square root of 5, all over 36 minus 5. So that gives me 31. So first my check is, did I get rid of my radical in my denominator? Yes, I just have 31. And then I would check, can I reduce this fraction or this radical at all? No, I cannot. Then I would say, are these numbers all divisible by the same thing? No, they're not. So this is my final answer for example 6. Okay, we're going to move on to 2 word problems. So if you have any questions on 1 through 6, please take the time and write them down now or come and ask me. Otherwise, we're going to move on to our last 2 word problems on this note sheet. So 7 says find the perimeter and the area of the rectangle. So remember, perimeter, it's just when you add up all your sides. So you take 2 times your width plus 2 times your length. So 2 times my width is the square root of 8. Plus 2 times my length is 3 plus 6 square root of 2. So if I start simplifying, this is really 2 square root of 8 plus, distribute this to 6 plus 12 square root of 2. Okay, I want to combine like terms if I can. I think about 8, and I can actually rewrite that. It's 4 times 2 plus 6 plus 12 square root of 2. The square root of 4 is 2. So I'd write a 2 out in front. So I'd have 2 times 2, which is 4 square root of 2, plus 6 plus 12 square root of 2. And I would say, can I combine any of those? Well, they are the same radical, so 4 plus 12 is 16. So I would have 16 square root of 2 plus 6, and this is perimeter, which is labeled in yards. There's my perimeter. Okay, we are also being asked to find the area. So area is length times width. So what we're going to do here is just take our length times our width. So I really have square root of 8 times 3 plus 6 square root of 2. I would distribute. So I have 3 square root of 8 plus 6 square root of 8 times 2 is 16. So I'm going to go ahead and simplify. 8, I know that that perfect square in there is 4, so it's 4 times 2 plus 6 times the square root of 16 is 4. I go ahead, bring my 4 out in front, so I have 3 times 2, so I have 6 square root of 2 plus 6 times 4 is 24. And there is my area, simplified all the way, and we label area as yards squared. Okay, so those are my answers for 7, the perimeter and the area. Let's move ahead. Let's move on to example 8. It says find the hypotenuse of a right triangle with legs 2ab to the second and 6ab to the second. So we might have a little help here. The help is Pythagorean theorem. So let's just go ahead and let's draw ourselves a right triangle. So it says find the hypotenuse. Remember, your hypotenuse is always across from your right angle. And then our legs, we have 2ab squared and then 6ab squared. So I need to find the hypotenuse, so I'm actually going to use the Pythagorean theorem. I'm going to call this h for hypotenuse. So we would have 2ab squared, all of that squared, plus 6ab squared, all of that squared, is equal to our hypotenuse squared. When you square it, notice there is no addition. Okay, so maybe something to take note. If I had this, okay, since there's addition, you'd have to write it twice and then FOIL with addition or subtraction. If you are multiplying or dividing, you can just square each part. Okay, so that would mean 2 squared is 4, a squared, and then remember you multiply, so it's 2 times 2, which is 4, plus 36 a squared b to the 4th is equal to h squared. So I would look, can I combine these? A squared b to the 4th, a squared b to the 4th. They're exactly the same. So I can combine them. 4 plus 36 is 40. A squared b to the 4th is equal to h squared. Now I want to find the hypotenuse, so I have to take the square root and simplify all the way. So I would say perfect squares in 40. 4 times 10, a squared b to the 4th. This is going to give me my hypotenuse. Square root of 4 is 2. Square root of a squared is a. Square root of b to the 4th, 4 divided by 2 gives you 2, so b squared. Square root of 10. So our hypotenuse is 2ab squared square root of 10. Okay, and that is it for example 8. If you have any questions on it, please let me know. Otherwise, have a great day, and I'll talk to you later.